All right, today we're going to finish up our notes over conic sections, and we're going to talk about the weirdest one, which is hyperbolas. Basically, we've kind of talked about what these all are. These are conic sections. So if you take a cone, we've talked about how these are different cross sections of cones. The hyperbola is a really weird one, though. This is like if we put two cones end to end by the tip of the cones. So we have two cones like this. Okay, so we talked about how a circle was a cross section of a cone this way. A parabola was like when we cut the edge off, we create a parabola. An ellipse is when we take like a diagonal cross section of a cone. And now we're going to look at a hyperbola, which is like if we cut through two cones like this. So we create like a parabola over here along with another parabola up here that have this kind of gap in between. So it's kind of a weird shape. It does follow a lot of the same rules as our other conic sections, though. And you can see your two graphs right here. Here's one, so that's like if our cones were side by side this way. Okay, and then this one goes up and down more like this. So we see we have this parabola at the top and this parabola at the bottom. On this one we have the two that go side to side. Okay, so kind of a weird shape, and there are a lot of little details here, so you want to make sure that you're paying attention to the notes and taking these notes down well. We will have a work day again tomorrow when I'm back with you, and so I will expect that you know this stuff because you're listening to these notes and taking good notes now. Okay, so we have a lot of things to look at. Just like all of the other conic sections that we've had, we have a vertex, and that vertex is this point and this point right here. We actually have two on this. Okay, so I'm going to label that V, and that one is also a V. So it's where our graph hits that very middle point right there. Okay, with these we also have something called a covertex. Okay, so this is CV, a covertex, and here also is another covertex. All right, so we see that we get this little box kind of formed with the vertex and the covertex, so we have kind of a little box. This is kind of like with an ellipse, but an ellipse we just drew an oval shape around those. All right, now we're going to do a little something different with those. It's like we're taking an ellipse and we're turning it inside out, maybe. All right, we also still have our focal points. Okay, so here's a focus, which is inside one of the little parabolas and on the other side as well. Okay, so we have a focus on each side as well. We call this big axis that goes through the graph, we call this the transverse axis. All right, so when the transverse axis goes side to side like this, it's horizontal. When the transverse axis on this one goes up and down, we call it vertical. Okay, so this is horizontal, and so we could fill that in the boxes down here. Transverse axis here is horizontal. Transverse axis here is vertical. All right. We can go ahead and put the vertices, the covertices, and the foci on this graph as well. The vertices now are here. The vertices always fall on the transverse axis. So here the transverse axis is vertical. Here it was horizontal. Either way, the vertices fall on that. Covertices are out here. They actually don't even touch our graph. Okay, the graph is really these darker lines here that look like two parabolas. So the covertices don't actually even touch the graph. And then our focal points, again, are here on the transverse axis near the vertices. All right, there's one other important thing that we need to talk about here. We've got this little box that's formed. And when we make the graphs of these, when we get down here to these examples and we're actually drawing the graphs, we will draw this little box, and then we're going to draw diagonal lines that cut from one corner of the box through the middle all the way to the other side. Okay, and again, I'm making little dotted lines because these are not really part of the graph. They're kind of imaginary lines. Okay, and these little imaginary lines are called asymptotes, which is a really weird word. Asymptote. Okay, so look at my spelling there. A-S-Y-M-P-T-O-T-E. So a very strange word. So these are asymptotes. All right, so you might have fun saying that a few times. It's a pretty funny word. All right, so each graph has those. They cut diagonally through this little box that we've created. An important thing is that our graph never touches the asymptotes. We put those there so that we can see our graph is getting closer and closer to them all the time, but not quite touching them. All right, so make sure when you're making your graphs, you kind of sketch these little asymptotes. You'll sketch this little box, and we'll make sure that our graph never actually touches those. So we've got kind of a crazy little picture right here, okay? Crazy little looking pictures, but the real graph are these dark lines that look like two parabolas facing away from each other. Okay, let's look at the forms of the equations. These are a lot like ellipses. Okay, we remember that with ellipses, we had our structure kind of looked like this, where each part is squared and it equaled 1. That is still true when we are looking at the form of an equation for a hyperbola. Still going to be equal to 1. Now in the middle, though, is going to be minus instead of plus. Okay, and we're still going to have our x minus h and our y minus k. So far it's very, very similar. The only thing that's different is a minus. Now with the ellipse, what we found out was that we knew which variable underneath was a based on which one was bigger. So sometimes a was in the front, sometimes a was in the back. That is not true anymore. What we're going to see with the hyperbola is a is always in the front. And I'm going to put a note of that over here off to the side. A is always first in the equation. Okay, so you may want to make that note. So now when I'm looking at this, A is always right here under this very first part of the equation. All right, so let's look at our vertical equation is right here. There always has to be something different though, okay? But like I just told you, A is always going to be first, which means B is always going to be second. It always equals 1. Now, though, what changes for horizontal to vertical is where our x and our y go. The h and k always will stay. Like h will always be with x, k will always be with y. But now we put the y minus k part first, the x minus h part second. So we got to pay really close attention when we're finding like the center of these. And I didn't mark those up here, but the center is obviously this very middle point of our graph. Okay, so we'll have to watch very closely as we're finding our center. So again, the center is always going to be HK. Okay, we'll just have to be careful when we're looking at this to know which one's H, which one's K. All right, the definition of A is the distance from the vertex to the center. Okay, so from a vertex to center is A. Sometimes, like you'll see right here, actually in both of our graphs, the vertex is closer than the co-vertex, which we didn't see that a whole lot with ellipses. But in this situation, it's not that A is always bigger, right? It's just that it always comes first in the equation. So sometimes A will be smaller than B now. Okay, B is the distance from a co-vertex to the center. C is the distance from a focus to the center. Okay, and then the relationship of A, B, and C, just like yesterday, or very similar to yesterday, is A squared, but now it's plus B squared equals C squared. So it reminds us a lot of the Pythagorean theorem here. Okay, so A squared plus B squared equals C squared. We remember with ellipses, it was minus there in that spot. Okay, so this is all the information we need to do some of these examples. This was a lot of information. Make sure your notes are totally complete, that you have all this picture drawn, and all of this stuff written down. We'll refer back to this table for each one of our examples. All right, we're going to keep our examples pretty straightforward just because these graphs do get a little bit crazy to make and stuff. So we'll walk through these two examples down here at the bottom, and again, we'll have another work day tomorrow, next time, to make sure that we're really getting this. Okay, so we see that we have an equation of a hyperbola. It's got a minus in the middle, equals 1, x, and all that good stuff. Okay, so it looks just like these formats up here. All right, we're asked to find the center, A, B, and C, and then we're deciding is the transverse axis horizontal or vertical. So we've got several things to find out here. Okay, honestly, I think the easiest thing to find out is it horizontal or vertical? Well, I see the difference between horizontal and vertical is x comes first if it's horizontal, y comes first if it's vertical. Okay, so x comes first in this equation, so this is going to be a horizontal graph. Okay, so what that means is when I look up here at my horizontal graph, I know my vertices are here on a line going side to side this way, and that when I make my drawing of my graph, it's going to be this way, not up and down like this one on the right. Okay, we also said A is always first, so I know that this number here underneath the very first part of my equation is A squared. So if 16 is A squared, then I know that A is 4. B is always the second part then, so B is 5, because the square root of 25 is 5. Okay, so we found a lot of our stuff. Now we got to find C, and we're going to use this relationship that we found right here to find C. So A squared plus b squared equals c squared. It's just like solving for the Pythagorean theorem here. All right, so I'm trying to find what does c equal. So I'm going to plug in what I know. 4 squared plus 5 squared equals c squared. Well, this is 16 plus 25 equals c squared. Continue going on. 16 plus 25 is 41 equals c squared. And now I just want to get an estimate, so I'm just going to grab my calculator here to find out what c equals. All right, so I'm going to take the square root of 41 and just get a decimal estimate. So 6.4, sorry, you guys can't see that very well. 6.4 is what I got for c. All right, and so that's an estimated answer, but it's pretty good. So here is 6.4. So here were the things that I was asked to find. Oh, one thing I didn't find is the center. Okay, so center, A, B, and C, and the horizontal or vertical. Center, we know it's the opposite of what goes with the numbers. Here's x and then y, so it is -2, 4 is my center. Okay, well now we're ready to make our graph. And again, guys, this is a really tricky graph to make, so we have to be kind of careful when we're doing it. I'm going to use like a black marker for all of the kind of invisible spots, and then I'll use my blue marker again for the actual graph. So we're going to do a whole bunch of things kind of faint, not very heavy writing on our paper. So let's find center, -2, 4. Okay, so left 2, up 4, and that is the center of our graph right there. I'm going to mark it with a C just so I don't forget that. Okay, I'm going to zoom in a little bit so you can maybe see this a little bit better. All right, then I know that my graph is horizontal, so I know my transverse axis goes side to side, which means my vertices go side to side. All right, and my vertices are A away from the center. So A left and A right. A is 4, so I need to go 4 to the left. 1, 2, 3, 4. That's a vertex. I need to go 4 to the right. That is also a vertex. Okay, so I'm labeling things as I go so I don't lose track. Okay, and all that good stuff. All right, now the other thing that I need to label is the covertex. So what I'm starting to do is make this box in the middle. I've got my center. I put both of my vertices down. Now I'm going to put both of my covertices. The covertices are B away from the center, so 5. And I've already gone side to side. I need to go up and down. So 5 up, 1, 2, 3, 4, 5, and 5 down. Okay, and I'm going to label these CV for covertices. All right, okay. Now I've created this nice little box. I can just kind of go down and up and across. Okay, I'm making a little rectangle that crosses through all those little lines. Okay, so I've got this little rectangle made, and I just drew it real faintly here. It's not really part of the graph. Okay, then remember we need to make our asymptotes, these big X's that goes all the way through. So I'm going to pick one corner of the box, okay, and I'm going to go all the way across with a dotted line, and I'm going to even go beyond the box. Okay, that's one asymptote, and then I'm going to do the other one across, and then I'm going to keep on going. All right. The one last dot that we can put on here that we haven't put on yet is the focal points, right? The foci. The foci are C away from center, all right? And we know that they have to also go on the same transverse axis as the vertices. So from the center, I'm going to go 6.4, or 6, and then a little more out from the center. So that's 4, 5, 6 and a half. Okay. So here's a focal point, and then I'm going to do the same thing over here. Okay. So now I've got all my dots. I've got all my little dotted lines and all this good stuff. Now I'm ready to actually draw the hyperbola, which is kind of weird to draw. Again, we're going to start at the vertex. Okay, look at our graph up here. We definitely go through the vertex, and then we're going to get really close to the asymptotes, without really touching them. Okay, so I'm going to draw kind of a curved figure that gets close to these asymptotes and doesn't touch. Okay, and then I'm going to go the other direction. I'm going to get close but not touch. And I'm going to do the same thing on the other side. Get close but not touch. Close but not touch. And that's our crazy graph of a hyperbola. Okay. Oh, and I was going to use blue marker for that very last line, and I didn't do it. All right, but you guys get the idea. All right, so this line here, these are actually the lines that represent the hyperbola. All right, let's try another one. Okay, so let's take a look at this line. All right, sorry, my computer kind of died there for a second. Okay, so let's take a look at this and see if we can graph this. So we need to find all these things again. Is it horizontal or vertical? Where's the center? A, B, and C, and then we can make our graph. Okay, so let's start looking. Here I see that the y part comes first. So when I look back at my table, I see if y is first, I definitely know that this is going to be a vertical graph. Okay, so it's the opposite of what we had over here. Instead of my hyperbola going side to side like this, it's going to open up and down, okay, and make those two arches. All right, and feel free to work ahead of me a little bit on this and then check your answer with me. This is something that you might want to start kind of practicing. Okay, the center is pretty easy to find. Okay. Center in this situation, and you know, maybe Miss Fender would want to hit pause right here and ask you to go ahead and do this one and check with your neighbor, and then just show this completed, worked out. Either way is fine though, if you guys want to just kind of do it with me. All right, so the center, we got to make sure that we switch around the x and the y, right? In an ordered pair, x always has to come first. So just because this comes first, this 2 comes first, doesn't mean the 2 comes first in the center. Okay, it's still HK, so -1, -2 is the center. A always comes first in these equations. So A is 2 because it's the square root of 4. B is 4 because it's the square root of 16. Okay? And then now we have to go through the process to find what C equals. 2 squared plus 4 squared equals C squared. This is 4 plus 16 equals C squared. So 20 equals C squared. I'm going to go to my calculator and just type in the square root of 20. Oh, not 290. Okay, there we go. And I get 4.47, so 4.5 is fine. Okay. All right, 4.5 is C. Okay, so now we're ready to go ahead and start making our graph. So let's find the center. -1, -2, that's left 1, down 2. So here's my center. Okay. My vertices are going to be 2 away from the center, but I have to make sure I go in the right direction. It's a vertical graph, so I go vertically up 2 and down 2 for my vertices. Okay, so there's a V there and a V here. My co-vertices are 4 away from the center. They're going to be left and right this time. Okay, there's a co-vertice. And then 1, 2, 3, 4, another co-vertex. Right, we need to make the little box, the little rectangle that goes through all these dots. Okay, the axis there is actually part of that box. And then we're going to draw our asymptotes. Okay, the asymptotes go crisscross. And please watch these examples more than once if you need to. Okay, so there's our asymptotes that cross through that. We can put our focal point on here at 4.5 away from the center. It has to be vertical again because it has to be on the same transverse axis here as the vertices. Okay, so 4.5 is 1, 2, 3, 4 and a half. That's a focal point there. And then here is another one. And then the last thing that we need to do is actually draw our hyperbola. This one is vertical, so it's going to be up and down instead of the side and side over here. Okay, and we're going to draw a big horseshoe shape that gets close to these asymptotes but never touches. Okay, same thing here. Okay, gets close but never touches. All right, so these are hyperbolas. Again, this is like if we were to take a cone, 2 cones stacked on top of each other and cut them this way, this is the shape that we would get. All right. Again, tomorrow's a work day, so please make sure that you kind of understand this material, but we'll clean it up and make sure we really, really get it tomorrow when we work together. All right, there you go. Enjoy the book. Make sure you keep cell phones and all that good stuff put away. Thank you.